Hey tens! Today we're going to learn more about absolute value equations. In part 1, we learned about solving basic absolute value equations. Now, we're going to explore some more advanced absolute value equations. Specifically, how to solve equations involving two absolute values. Some terms to know. An absolute value is the distance a number is to 0. Absolute value is always a positive number. I'm not going to elaborate on absolute value in this video, but for a more detailed explanation on what absolute value is, check out part 1, which is where I explain exactly what that is. So, let's take this equation. It's an absolute value equation. The absolute value of x is equal to 5. Now, if you're watching this video, you must know how to solve equations like these. So, how you would solve this is, since absolute value is the distance a number is to 0, and there are two numbers that have the same distance to 0, the positive variant of the number and the negative variant of the number, you would set this equal to the positive and negative variants of this number. So you would set x, removing the absolute value sign, equal to 5, and x equal to negative 5. And we already have our solutions there. Now, another way to write this is x is equal to plus or minus 5. That is how you undo an absolute value. And you'll see more of this further on in algebra when we are working with square roots and things like that. But now let's put absolute value around the 5 as well. Now we have two absolute values. How would we solve this? Well, that's what we're learning today. So let's move on to the next slide. So how do we solve for x? Well, it's pretty much the exact same as solving the absolute value equations we saw before. We solve for both the positive and negative variant of one of the absolute values. And this would preferably be the constant that's in the absolute value, but if there are variables on both sides, I prefer choosing the right, but you can choose whichever one you want. It doesn't really matter. But why does this work? Why can we do the exact same thing even though there is an absolute value? Let's take that equation again. The absolute value of x is equal to the absolute value of 5. Now here, there are technically 4 possibilities. One is that both of these are positive, so x is equal to 5. One of these are negative, so x is equal to negative 5, or negative x is equal to 5. Or both of these are negative. Negative x is equal to negative 5. But in these two, if you solve for x, here you get x is equal to negative 5, and here you get x is equal to 5, which is the same thing. And this is true for all other equations involving two absolute values. You can only have two possibilities because the other two are actually the same as the first two. So, moving on from that, there are some things to beware of. This was also explained in the last video. You must beware of extraneous solutions. Check your answers because sometimes you'll have a solution that is algebraically correct. You did the algebra right and you got the answer, but when you plug it in, it doesn't work. Another thing to remember is that absolute value is always positive. So if you end up with an absolute value equal to a negative number, just know that there is no solution to that because absolute value cannot be negative since it is a distance. Alright, let's try some examples. Let's take the first one. And before I show you the steps for each of these, I encourage you to pause the video and try both of these out on your own. Alright, I'm assuming that you've tried them out, so let's do the first one. The absolute value of 4x minus 11 is equal to the absolute value of x plus 4. Now, you see here, both of these have a variable on both sides inside each absolute value. So, what we're going to do here is we're going to set one of these two expressions equal to the positive and negative variants of the other expression. So again, I prefer to choose the right, but you can choose the left if you want. So I'm going to set 4x minus 11 equal to the positive variant of this, x plus 4, and I'm going to set it equal to the negative variant of this, but we'll get to that later. Let's solve this one first. So I'm going to add 11 to both sides and subtract x from both sides as well. So this results in 3x is equal to 15 divided by 3. And we get x is equal to 5. Now let's do the negative variant. 4x minus 11 is equal to negative, and in parentheses, x plus 4. Now, why in parentheses? Why not just put the negative in front of the x and leave the 4 alone? Well, absolute value acts like parentheses. So if an expression is inside the absolute value, you have to negate the whole expression. You can't just negate part of it and leave the other side alone. So we negate the whole expression x plus 4, and we end up with 4x minus 11 is equal to, we distribute the negative, negative x minus 4. Okay, now we add x to both sides. We add 11 to both sides. And we end up with 5x is equal to 7. We divide by 5 on both sides, and we end up with x is equal to 7/5. Now, we haven't boxed these yet because we don't know if either of these are going to be extraneous solutions. So let's do that. I'm going to check x equals 5 first. 4 times 5 minus 11, the absolute value of this entire expression, is equal to the absolute value of 5 plus 4. Okay, we don't know if this is equal to each other. So this becomes, sorry about that, the absolute value of 4 times 5 is equal to 20 minus 11 is equal to 9. is equal to the absolute value of 5 plus 4 is equal to 9. Now, the absolute value of 9 is 9, and the absolute value of 9 is also equal to 9. So this is correct. And x equals 5 is a solution. Now let's do x is equal to 7/5. 4 times 7/5 minus 11, the absolute value of this, is supposed to be equal to the absolute value of 7/5 plus 4. Now, an easier way to work with the fractions is to make the whole numbers the same denominator as the fraction. So let's just replace them. 4 becomes 20 over 5. 11 becomes 55 over 5. And we can leave the 4 alone because, well, all we're doing is multiplying it by the numerator. So that would be 28 over 5. So this is 28 over 5. Alright, so we've done that. Now let's see what we get. So 28 over 5 minus 55 over 5 is equal to negative 27 over 5. So we get the absolute value of negative 27 over 5. This is equal to the absolute value of 7 over 5 plus 20 over 5 is equal to 27 over 5. The absolute value of negative 27 over 5 is equal to 27 over 5. And so is the absolute value of 27 over 5. So 27 over 5 is equal to 27 over 5, and we are done with that. So x is equal to 7/5 is another answer. Alright, let's do the second one. The absolute value of 3x divided by 5 is equal to the absolute value of x minus 2. So again, I'm just going to choose to negate the right side because this one seems a little complicated. So 3x divided by 5 is equal to x minus 2, and we'll do the negative 1 after we've solved this. So we multiply 5 on both sides. That's not an x. We get 3x is equal to 5 times x minus 2. We multiply it by the whole thing. We distribute the 5. So 3x is equal to 5x minus 10. Now, what I like to do here is I like to just move these around so we have positive values instead of any negatives because I prefer not to work with negatives as much as possible. So we add 10 to both sides and subtract 3x from both sides. So we get 10 is equal to 5 minus 3x, which is 2x. Divide by 2 on both sides, and we get x is equal to 5. Now again, we're not boxing that because we don't know if we have an extraneous solution. Alright, let's do the opposite now. I'm just going to do it up here. 3x divided by 5 is equal to negative, in parentheses, x minus 2. Because again, we're negating the whole expression. We cannot ignore anything that is inside this absolute value. So again, I'm going to distribute these. I'm going to distribute that negative. So 3x divided by 5 is equal to negative x. Negative times a negative is a positive, so that is plus 2. Now we multiply by 5 on both sides. Again, that's not an x. 3x is equal to 5 times negative x plus 2. I'm just going to keep that separate. And we distribute the 5. 3x is equal to negative 5x plus 10. And again, I like to use as little negatives as possible. So I'm going to add 5x to both sides. And we get 8x is equal to 10. We divide by 8. We get x is equal to 10/8, but that can be simplified to 5/4. Alright, now let's check with the room we've got left. I'm just going to hope everything fits in here. Okay, so x is equal to 5. We're going to check that first. And so the absolute value of 3 times 5 divided by 5, so the 5's cancel out here, we're left with 3, is equal to the absolute value of 5 minus 2. And we end up with the absolute value of 3 is equal to the absolute value of 3. And this becomes 3 is equal to 3. So that's good. I'm running out of room. Okay, I'm just gonna do it up here as small as I can. So let's check. X is equal to 5/4. And we do the absolute value of 3 times 5/4 over 5. Oh gosh. Is equal to 5/4, the absolute value, minus 2. So again, I prefer to change the whole numbers into fractions that have the same denominator, so I can work with like fractions. So 2 becomes 8 over 4. And I'm going to leave this one alone. So this becomes 15 over 4 divided by 5, which is 3/4, is equal to, so absolute value of 3/4 is equal to the absolute value of 5/4 minus 8/4, which is negative 3/4. And we get the absolute value of 3/4 is equal to, okay, just gonna make some room here. 3/4, and the absolute value of negative 3/4 is also 3/4. So this answer works, and I haven't run out of room. Yay! So x is equal to 5/4 is also a solution. Well, hope you liked this cramped slide. But anyways, thanks for watching. If you liked this video or this helped you, click that like button. If this didn't help you, click the dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions related to this topic, please put those in the comments below. And remember, the comment section is the equivalent of a class discussion, so if you have any answers to any of those questions, you may answer them. If you have any suggestions for what I should do next or how I can improve my future videos, please put those in the comments below as well. If I like your suggestion, I'll be sure to include that in the next video and give you a shout out. See you in the next one!